Alright, we want to learn now that we know how to graph quadratic functions by hand, we want to learn how to do it on a calculator, and I'll be trying to use one of the TI-80, I believe it's a TI-84, that those tend to be the most commonly used. If you do have another calculator, there's probably some directions in the owner's manual or online about how to use it, but I'll be using the TI-80 just to show you how that works. So the goal with this, some equations can be done by hand, but some of them are more complicated, especially when you have word problems. So we'll be doing, on the right side, you can see there's a baseball example that we'll be using. I just want to show you in the first example the basic way to do this. So we have to take the following function, we have to graph it, and you could do it by hand, but this will be, especially locating the zeros, there's no easy way to do some of these without the calculator. Locate the zeros. So first of all, the zeros, if you're just wondering what that terms mean, let's suppose you had a graph right here and this is your parabola. Okay, the zeros are what I'm marking right here in green, and the reason those are called zeros is because that's the line y equals 0. That's what solves the equation. That's what tells you when the parabola actually reaches 0. So those are usually the most interesting points on the graph, depending on what kind of problem you're trying to solve. So our goal here is we want to put this function right here in the graphing calculator. We want to find the zeros. That means where does it meet the x-axis. And then we also want to find the maximum or minimum point. And even before graphing this, we can already tell parabola only has a max or min. This one that I drew up here that I'm marking, we mark a different color in purple right there, that obviously is a minimum point because it's the lowest point on the graph. How can you tell even before graphing if it has a max or a min? And the answer is based on that number. Since that number, a, and by a I mean when you write a quadratic in standard form, it looks like this: a number times x squared plus a number b, which we're calling b, times x plus a number c. If a is positive, then the parabola is going to open up like that. And if a is equal to a negative number, the parabola will be pointing down like that. And I'll show you an example of each. Alright, so let's enter this in right now. 1/2 x squared. I'm going to put in 1/2 as 0.5. It's a little bit easier to do that on the graphing calculator. So 1/2 is going to be, let me just see if I can expand that a little bit larger so you can see. So we have 0.5 x squared. The x button is, it just lit up in red right there. It's kind of towards the top of the calculator, and then the squared, every time I click a button it's going to light up in red so you can see it. And then after that we had minus 2x, so minus 2x and then minus 2. Alright, once you have that, you can press the graph button, which is in the top right corner, and if it doesn't give you a good picture, I'll show you what to do. This is giving us a good picture. If it doesn't give you a good picture, what you can do is go to zoom, and then if you use the down arrow, go to zoom standard. Zoom standard will give you the normal window, and you can kind of see it popping up there. If zoom standard doesn't work, go down a little bit further and there's a button called zoom fit, and usually either of those will give you a good picture. We'll just stick with zoom standard for now. Alright, so here's what our graph looks like, and remember we had two goals. We want to find the zeros and we want to find the minimum point, because you can see that opens up, so it's minimum. So to find the zeros, you hit second, and then there's a button up here that says trace. I just clicked on it. Right above trace says calc. So second calc, we want to find the 0, so I'm going to go down to 0, press enter, and right now you notice that there's 2 zeros, so this is important. The calculator right now is saying left bound. What that means is you need to tell it which 0 you actually want to find, because it's not going to know. There's 2 zeros we can find, so I'm going to tab this arrow over. I'm pressing the arrow, and right now you can see that I'm on the left of that 1 0, the 0 on the left side. So I press enter. Okay, then I go over slightly to the right of it, and you can see how those two blue lines just showed up. They're a little bit faint, but now the calculator knows exactly which 0 you want. It knows that you're not telling it to find this 0, just scrolling over here. You're not telling it to find that 0 way over here on the right side. It knows to restrict itself to the left. Alright, so I'm just going to move this back, and then finally it says guess. You can really just hit enter again after you hit right bound. I'm just going to go pretty close to the 0, make a guess where it is, press enter, and there's our first 0. Our first 0 is x equals negative 0.83. That means if you were to plug in negative 0.83 to that original equation, the 1/2 x squared one that we typed in, it would cause it to equal 0. Let's find the other one. So I'm going to go to second calc again, press 0 once more, and now I want to find this other 0, the one on the right side. So it says left bound. I'm now on the left side or right below that right 0. So I don't want to confuse you. We're not on the left side of the graph. We're on the left side of the 0 we're trying to find. Now I go a little to the right of that 0. I'll press enter one more time for a guess. And our other 0 is x equals 4, about 4.83. So there's our second 0. And then the last thing we had to do is find the minimum point. So I'm going to go back to second calc. You can probably guess which one I'm going to pick. I will pick minimum right here. And the minimum point, we have to do the same thing. So I'm going to go down a little bit to the left of the minimum, press enter, a little bit to the right of the minimum, and press enter once more. And then finally I'm going to go pretty close, and the minimum point occurs at x equals approximately 2. Sometimes the calculator does that weird kind of rounding thing, but it's clear that it's going to be at x equals 2. I don't know why they did 1.999 like that. It's x equals 2, y equals -4, which is also the vertex. And you might remember finding the vertex with negative b over 2a. You can test that out, and it will in fact show 2, -4 as your vertex. Alright, here's a more common example. A more common example would be this problem right here. It's a baseball problem. A lot of physics equations are modeled by parabolas, and a baseball is a good example if you think about it. I'm not a good artist, so please pardon me in advance, but let's suppose somebody's standing here holding a baseball bat, like so. Again, horrible picture, but the ball is coming in this way. He's going to hit the ball, and the ball will travel roughly like that. It's going to come off the bat, and it's going to look like an upside down parabola. Okay, that's why this number right here is negative, because it's going to be a negative or upside down facing parabola. Okay, so what does this equation actually mean here? Because it looks a little bit confusing, and actually this should be a t right here, not a v. Basically says the path of a baseball, and the path meaning this picture, after it's been hit is modeled by this function right here. H sub 0, so h with that little 0 stands for the initial height. So obviously when this guy right here is hitting, he's holding the bat a certain amount off the ground. He's not, batting while kneeling on the ground or lying on the ground. So it says Giancarlo Stanton, who, if I'm not mistaken, as of when I'm making this video, I think he plays for the Yankees. I could be wrong. He hits from an initial bat height of 5 feet. So I'm going to rewrite this function with the information they're giving us. So -32 stays the same. That's based on the speed of gravity, the speed that the ball is going to fall down. T squared, T stands for time, plus v sub 0 stands for the initial velocity. So obviously when you hit a baseball, it's going to come off your bat at a certain speed. They're telling us it's coming off his bat at 100 feet per second. So I'm going to put 100 right there where there used to be a v. And then finally h sub 0 is the initial height, and it's telling us that he's standing, or his bat is 5 feet off the ground. Let's say he's 6 feet tall. That might mean his bat is at shoulder level, so 5 feet. So here's the thing that we have to graph, and then we'll use that to answer 2 questions. What's the highest height that the ball reaches? That's like asking for this point right here, the maximum. And again, it's a maximum because it's upside down facing parabola, because that's a negative right there. Finally, and then the second question, how many seconds after contact does a ball hit the ground? So I want you to think about this. See if you can pause and try to graph that and answer those 2 questions. What's the highest height that the ball reaches? That's another way of saying what's the max. Second question, how many seconds after contact does the ball hit the ground? Well, think about this. What is the height of the ball when the ball hits the ground? And the answer is the height when the ball hits the ground, the height is going to be 0, right? It's going to be right here. At that point, the ball has hit the ground. It's not any distance above the ground, so it's going to be 0. So see if you can pause and answer that, and then we will go through this. Alright, so I'm going to graph this. Let's go back to, by the way, when I pressed y equals, that's in the top left corner. That's where you go to graph things. And I'm going to put negative. This is important. Hopefully you just saw that negative that lights up in the bottom left corner. Use that instead of this minus key, because you'll get an error if you use minus. Minus means subtract. The negative is the very bottom. That means negative. There is a difference. So, and you can see there, right in the middle, they showed a syntax error because I did that wrong. Okay, we said -32t squared, but I'm going to use x because it means the same. And h, by the way, h of t stands for height. That's the same as y. So -32x squared plus 100x, and then we have, I believe it was plus 5. That was the initial height that he hit it, so plus 5. So I want to show you what happens when I graph this. It's probably not going to give me a good picture. Let's see. Yeah, and you can see it's actually not giving me a good picture at all. It is a picture, we can't really see it. So now here's where we can go to zoom and then go to zoom standard. We already know that's not going to work, so I'm going to do, you can also use zoom in and out, which you see up top. I'm going to use zoom fit just to see if that gives us a better picture, because obviously he's hitting, sorry, these arrows are a little bit unpredictable here. He's hitting a baseball, so it's not going to be the standard 10 by 10 window. So that is, that's not great. Here's how we can fix that, though. I want to get a little bit more height on the Y right there, because I want to be able to see what the max is. So I'm going to do this. We'll go to window, and that just lit up right there. And then our minimum X value, let's set that to 0, because remember, X stands for time. You can't have negative time. Okay, the X max, we'll keep it at 10. The ball's probably not going to be flying for 10 seconds. This SCL stands for scale. Usually you take the max and divide it by 10. So that tells you how many tick marks it's going to put. So 10 divided by 10 would be 1. So that's a good X scale. The Y minimum, we don't need, first of all, the height is never going to be smaller than 0. So we can, let's put negative 5 right here, because we do want to be able to see where it hits 0, but obviously you can't have a height below 0 unless the ball is going to go into the ground. And then how high is it going to go? Let's just stick with 30 feet for now. If we need to change that, we can. And then I'm going to divide 30 by 10 to get the Y scale. So this, I believe, is going to give us a much better picture. Let me just put this up to 40. I think it'll give us a slightly better picture. If not, we can always adjust it as needed. Alright, so let's see what that graph looks like. Well, yeah, you can see a little bit better, but we still want to, sometimes you have to experiment a little bit. We'll play around with the window a little bit more, because that's not high enough. Let's try 90 feet this time instead of 40, and now we'll divide 90 by 10 to get 9. I think this should be a little bit better. Good, this is good. So now we can see two things. We can see when does it hit the ground, when's the max. Let's start with the max. So we'll go to second trace or second calc, and we want to know the maximum. We want to know when does it hit the maximum, and then what is the maximum. So right now you can see those numbers changing at the bottom. My Y, you can't see where the arrow is right now, so I'm just tabbing over with the arrow and it will come into focus, and now you can see it. So we want to go to the left, press enter, go to the right, press enter, enter one more time, and the maximum height of that ball is 1.5 seconds, about 1.56 seconds after he hits it, and it hits a highest point of 83 feet. So there's our first answer. Second answer, when does it hit the ground? And that's another way of saying when does Y equals 0. So we're going to hit 0, and then we have to go down to this one right here. The other one is not going to make sense, because the other one is in, you can see on the left side of that parabola, it's in the negative zone. We can't have negative time. So I went to the right, and then I'm going to guess. So it hits the ground. I know it says Y equals 1e to the negative 11. That's basically 0. That's another way of saying 1 times 10 to the negative 11. It hits the ground after 3.17 seconds. So that's how you can use a graphing calculator. This is a TI-84, but that's how you can use a graphing calculator to solve word problems with parabolas. Hopefully that makes sense.